In our last tutorial, we created the part of the expression that would allow our arrows to indicate as to which snake is the overall winner, or which combination of snakes have taken part in any one of 4 dead slither scenarios. We tested it out to make sure that it was working, and it was working fine. Since I finished the last tutorial, I've actually changed the wording in the last couple of remarks here. Instead of calling them checksums, I've decided to call them triggers, because in fact this is a more apt description of what these actually are, these particular ones at the bottom here. That's the only thing I've changed there, and I've also gone on to label our conditions here just so that we can have greater clarity as to what's actually going on with these. So that's the only changes I've made there. The next thing we need to do here, which is our objective for this particular tutorial, is to create the part of the algorithm that will actually cause the arrows to animate as and when they are required to do so. So to begin at the beginning, what we first need to do, we've got the two-way dead slither activator here, so we'll create the part of it that checks for a two-way dead slither first. We'll start there and work our way down from the top systematically. If I move over here a little bit, what we're going to do is work with our dead slither checks, which are over here. I'm going to just bring the view to 100% so that we can see exactly what we're working with. The first thing we're interested in is looking at these two-way compares here. Are we equal to Sid Nancy, Sid Bonnie, Sid Clyde and Sid Dave? Because what I'm going to actually do here is create the expression for Sid's arrow first and then do my usual thing of copying and pasting for the remaining snakes. It's just the easiest way to work, so we're going to proceed that way as per usual. First thing to do, come down to the bools yet again, bring one in, and it's going to be an AND, so I don't need to alter its function. Just need a couple more inputs there, make it a little bigger, and then it's a case of copying it 3 times because I need 4 of them. Just get that out of the way a minute. Just bring that down there and that down there. So that completes that part. Just bring those up into there so that I can work with them more easily. First thing we need to do is plumb in Sid and Nancy to the top of this one, Sid Bonnie into the second one, Sid Clyde and Sid Dave into the bottom one there. So for a start, we're saying if there's been a two-way dead slither, is it the case that Sid is equal to Nancy, equal to Bonnie, equal to Clyde, or equal to Dave? Are any of those scenarios true? If none of them are true, then Sid is not a snake that's involved in a two-way dead slither. That gets this part of the setup underway with the first check that we need to make. Just get these down to the bottom here, because the next thing we've got to do is make sure that if Sid has drawn with one of the other 4 snakes, that his and their scores are actually higher than the other 3 scores. Because as with the 3-way scenario, we have to be sure on this occasion that we don't have a second pair of scores drawn with the second pair being lower than the first, which could cause us a problem. Because if we didn't bother to check for that, and we simply said, is there a two-way slither between the snakes, we might get a two-way slither between Sid and Nancy, along with a second two-way slither between Bonnie and Dave, thereby causing 4 arrows to be animated. And that wouldn't be any good. So we've got to be a bit careful there and make sure that we're greater than the remaining scores. So our first bool here, we're checking, are Sid and Nancy equal? That being the case, we've got to make sure that Sid's greater than Bonnie, Clyde and Dave. So we can plug the outputs from their compares into the inputs of our bool over here. So those 3 compares are plumbed in there. Next one down is Sid and Bonnie. Are they equal? That being the case, we check Nancy, Clyde and Dave. We make sure that Sid's greater, or Sid's score is greater than those. Moving on down, we're checking, are Sid and Clyde equal? So are we greater than Sid Clyde, or Sid Bonnie I should say, not Sid Clyde, Sid Nancy, the first one, Sid Bonnie and Sid Dave. And finally we're checking Dave, so it's the first three that we need to worry about. Okay, and Sid Clyde in that one. Okay, so that's the first part of this check done. We just quickly look at what we've got. So we're saying here, are Sid and Nancy's scores equal to each other? And is Sid's score greater than Bonnie, Clyde and Dave's scores? If all the answers to those 4 questions are true, then the output of our bool is also going to be true. And the same applies to the remaining 3 bools here. So that's what we've set up there. We just move this, oops, not like that, just want to move it over to here, get it in place. Somewhere there. Should do nicely for now. Okay. Final part of this check is to get a 5th bool. Once again, give it 2 inputs on top of the 2 that it already has, and then set it up there. We connect all of these here. Change its function to OR because we're only interested in one of the 4 scenarios being true. And we now have our first checksum set up. Okay, so that's our 2-way checksum set up. I will put a remark in there, but not at the moment. I'll just leave it for now. Next part is to bring in the condition. Place it here. We'll leave input 2 here empty because we don't need anything in there, and we'll plug this into there. So our condition here will be switched by the output of the bool from the 2-way dead slither checksum. So we'll plug that in there. So if there has been a 2-way dead slither, this will be activated, this will be switched, and we'll be checking to see if Sid has been part of the 2-way slither. Any one of these scenarios is true, he has. If they're all false, he hasn't. So his arrow won't be activated by a 2-way slither scenario. So that's the first part of the setup. The next thing we need to check for is a 3-way slither. Has there been a 3-way slither? That's the next thing we need to ask. Once again, it's a bool that's required. This time with 6 inputs. Just make it slightly bigger. I'm going to bring this over here actually and work with it over here because again it's much easier. So just slide things over here. And this time what we're looking at are any 3-way slithers. So we're looking at all of these that involve Sid. And it's the first 6 basically that we're interested in because they're all Sid. We've got Sid, Nancy, Bonnie. So that goes in the first input there. I just want to move that out of the way of the wiring just in case I trip over one of those and unplug it. Sid, Nancy and Clyde. Sid, Nancy and Dave. Sid, Bonnie and Clyde. Sid, Bonnie and Dave. Sid, Clyde and Dave. That's how we set that up. We don't have to check for whether they're actually greater than the other 2 scores because we've done that previously, and it's a case of if there's going to be a 3-way dead slither, don't need that, if there's going to be a three-way dead slither, then this is going to tell us that there has been anyway. Those checks, in other words, those checks have already been made. So if there's a three-way dead slither coming out of here, this will activate. If there hasn't been, then it's not going to activate anyway. So we don't need to worry about checking for that twice. So that's why we've only got that single bool there, and we don't need to worry about anything else. So hopefully that explains that one. Okay, so I've got my bool set up there. My three-way. Next thing I need to do, I'm going to copy this condition across, place it there, and I can plumb in my three-way output into input 2, or rather input 3 I should say, of the condition there, and this one can be plugged into here. The switch is going to be activated by our three-way checksum there, so that's plumbed into there. So that's our next setup worked out. Just move that up so that we can see the cabling a little bit more clearly. That too, I'll just leave a little bit of room there because I will put remarks in. So we've got a two-way check and a three-way check in place now. Next one we need is a four-way check. So once again, it's our friend the bool. That one, it needs to be set up as an OR because we're only interested in any one of those scenarios being true. So we need to set that up. This one again is going to be an OR, so we'll set that up right away. Give this a couple more inputs. This is where it will finally end up, and we'll put it over here for now because again I'm going to work with it over near the four-way slither checks. Okay, so the dead slithers here for Sid, Nancy, Bonnie, Clyde, Sid, Nancy, Bonnie, Dave. So it's going to be the first four that we're interested in because they all feature Sid. We can leave the last one. Finally, Sid, Bonnie, Clyde, Dave is the last one there. Can plug in there. And that's our four-way slither checksum for Sid's arrow set up. Get it into place somewhere around here. Once again, copy a condition node, place it there, put the four-way check in there, plumb the output from the previous condition into there, and yet again we go across to our output of, let's just move it over here so we can see. Right, so we want the output this time of our four-way slither activator there. To switch that one, so if there's been a four-way slither, we can check to see if Sid's been part of it. Okay, so that can go in just about there. Next thing we need is purely another condition. And this is for the absolute slither check. So we might as well just plug or plumb that one into there because our absolute slither check is going to go from here. We'll then drag her over. And we need the output from this bool here because that's the one that checks for the absolute slither. So we simply need to take the output of this one and plug it into the bottom there. And that's it. That's all we need to do with that one because that's all taken care of. Just get it through. Place it about there. So that's our absolute the condition. Absolute slither condition, that's what I'm trying to say. Just move it over here so we can plug the output of the bool in there from the absolute slither activator. That's that one there. And now it really can be placed back over here. Finally, we just need our overall winner condition. So for a start, we can plug this into here, bring it over here. The switch is obviously going to be this trigger here, this final bool, the output of there. So that's the switch for it. And we just need to come over here, grab a hold of our output from Sid's check there. So we've checked here, is Sid greater than the other snakes? Is his score greater than the other snakes? So that's the overall winner check that we're doing there, that will trigger the arrow. And just bring that into there. And that completes all of the checks that need to be done. The two-way, the three-way, the four-way, the absolute slither, and finally the overall winner. So all the checks completely done. Any one of these scenarios is true. We know that Sid's arrow needs to be indicating that Sid's score is either the winning score or he's a participant in one of the 4 dead slither scenarios. So that's what we're doing there. I'm not going to run tests on this now because I think it's just as easy to set the arrow animation part of the expression up, and then we'll check to see if it all works. As before, we've done this one a number of times, so what we need a monoflop. The trigger for it is going to be the output here, and a true result is going to activate it, so we can plug that straight into the monoflop. We've got to make it, once again, a one-shot monoflop in the mode here. We need to give it a state port. We need to set the duration to 15 frames. We want this to last 15 frames, this part of the animation. And then what I'll do, I will frame everything, grab a hold of the monoflop here, get it near the time node as per usual, frame selected, and plug the output from the time port there into the time port of the monoflop, frame all again, grab a hold of it and put it back in place where it needs to be, which is somewhere about there. That'll do nicely. Okay, ooh, don't want that. Just want to frame these. Frame selected. Okay, that's great. Moving on from here, I need a range mapper. Just shunt that out of the way. As per usual, my state can just plug into the input of the range mapper because that's absolutely fine. It's between 0 and 1. The output upper needs to be, it needs to be the case that the arrow is moving from within here, which is the 0 position. It needs to come to about the centre of the top 0 to indicate Sid's score, and that's from 0 to 443 centimetres. That's what I've worked it out to. So 443 is what needs to go in the output upper there. Moving on from here, as per usual, I need my 2 compares. No, I beg your pardon, 2 conditions. I'll get my 2 conditions. So the first one, which will be going there, my range mapper, well, the first condition, I'll set that up anyway. It's going to be 0 because this is the one that's going to lock the start and finish positions as per usual. So 443 is going to go in there. And then following on from here, I need my second condition. My output is going to be the switch for that one, of course. So we're going to be using our range mapper when the monoflop is running, and when it isn't, the output from condition number 1 is going to be in there. And this condition will be triggered by our output here. Let's just move that down a little bit so that we can sort of see what we're doing a bit more. Put it in there, put that in there. That's a little bit tighter, that's great, so we can see our wiring nicely. So that's absolutely fine, and then the final part is simply to grab a hold of Sid's arrow here, place it in there, come down to coordinates, position Y, and plug the output of our second condition into there. And that, we zoom out a little bit, and that completes this part of the expression. So Sid's arrow setup is absolutely complete now. The next thing I suppose we should do is test this and see if it works. So what we've got, we've set up here with our constant node a winning situation for Sid, because we've got a number 1 in there, so Sid's score is definitely going to be higher than all of these because they're 0. So let's see if we can make this work and see if we do get Sid's arrow flying up, see what happens. And indeed we do. It works perfectly. The one thing that we do need to do, as per usual, just to make the arrow a little bit more dynamic, what we'll do in the range mapper here, we'll go into the spline. And what I will actually do, I'm going to bring this into a separate window. So I've got my spline here that I can work with. So what I'm going to do, I'm going to put a point there, just drag it down to there, point here, and I'm going to sort of flatten it off a little bit here to start off with. This is just to create a slight pause before the arrow flies up. When I get to somewhere around, I suppose here, I'm going to put another point in there. Push this one up here. We'll play around with the handles here. We're just going to make this slightly higher there. Put another point in here, drag it down a little bit, and we're going to need to do some work, so we just need to drag this handle up there just to make that slightly above. And we want that one slightly below. Put another point in there and make that one slightly above there. And I'm going to hold my shift down and just operate this other handle so that I can play around here. Just get that where I want it. Just make sure I've got that what I need. So look, see if we can just get these sorted out. If I can break the tangents on that one actually and just shift it around, if it'll let me. Okay, let's just get that where I want it. Push this one in here. I think we can probably bring that one down a little bit there. Put this one, another one on there. Place it somewhere there. Draw it in and get it somewhere sort of flattish. What I'm trying to do is create a sort of little bit of a kind of an oscillation or vibration in the thing when it comes to a standstill. Just make it a little bit more dynamic than it would be if we didn't do that. Lower that down a little bit. Break the tangent on that and something like that hopefully might help us. You can play around with this to your heart's content really, but something like that might well help us. Let's just see what we get there. It doesn't have to be 100% perfect, it's just, you know, there's ways of playing around. That's fine, it all resets itself as it should, which is great. Let's see what we're going to get here. Well, it's not perfect, is it? Not by a long chalk. It's kind of a little bit better than it perhaps was. Let's just go back into this again and have another little play around with it, see if we can get it just a little bit more dynamic than it is. Take that a little bit higher, take that one a little bit further along maybe, so that we give it a chance to really sort of do something. Move that a little bit out that way. We're trying to create a kind of a damped sine wave here. That's the kind of thing we're trying to create, just to give the animation that extra little bit of realism that I like to see in it. Just move that over. This might work quite nicely now. It's not far off, I don't think. Let's just try that. Let's see what that does. It's just... But as I say, it's pure experimentation with this stuff, and you can do it to your own taste. There's no absolute right or wrong way to do it. Let's just see what happens. Yeah, that gives a quite nice little jerk there as it comes into place. That's exactly what I'm looking for. So let's just run that again and see that again. It's quite nice, I think. Yeah, that's great. That's exactly what I'm looking for. It makes it quite nice, that does. Okay, lovely. So we've got that working, and that's looking very, very nice indeed. So the next port of call for me is simply to copy all of this another 4 times and plumb it into the other snakes. Now in the range mapper, obviously things are going to be slightly different in the others because we want to indicate the individual scores. What I've done in here, it starts at 443 and I've done them at intervals of 80. So the next one will be 363, then 283, etc., for the other 2 snakes. So that's how I'm dealing with that. Okay, that's absolutely fine. So what I'll do then, I'll just pause here, I'll copy everything over and plumb it all in. I'll give you a thorough explanation of what I've done, and then we'll test the thing out with various scenarios and see if it does actually do what we want it to. We now have everything completely copied and plumbed in as need be. And as you can see, the wiring now looks absolutely horrendous. It's very, very dense, but as before, it's a case of just working systematically and building it up, and before you know it, you've actually sorted it all out, and it's not really as awful as it looks. Let's just have a quick look at what we've actually done, because obviously I've got the 5 algorithms here. You can see where they are. I've put some remarks in for each snake's arrow to help us out with identification of what's actually going on. So if we just frame Sid up here for the moment, we have a quick look at what we've got. So with the remarks, I've simply put 2-way checksum to give us the idea of what we're doing there. The 3-way checksum is here, the 4-way, and then up here the absolute slither trigger and overall winner trigger checks. So they're those 2 there. So they're the important bits that actually make the arrows trigger at the correct times. Coming down to Nancy here, I showed you how to wire Sid in, but we'll just quickly go over what we've done with Nancy. So if I select the bools here for that 2-way check, just frame selected, or rather, actually we'll frame all. Right, okay, so once again, when you come to wire the remaining snakes in, what you can do is use a table to help you out again, and of course, by the magic, we have one here. Now, obviously, so the first ball at the top there, we're comparing Nancy with Sid. So this is Nancy with Sid, and we can follow this through, and we're taking anything from the 2-way dead slither checks here that involves Nancy. Second one down is Nancy and Bonnie, then Nancy and Clyde, Nancy and Dave. These all plumb in from here, from over here, into the top or input number 1s in each of the 4 bools there. Following on from here, the tied scores are compared to the remaining snakes from each of the 4 compares under Nancy here. So we're checking that she's greater than the remaining 3 snakes in the various combinations that we need to check them in from this set of snakes here. It's as simple as that, and you just follow that rule through for the other snakes. So the top inputs are always the scores from the snakes that you're comparing to being equal to. The remaining 3 inputs are used to check that the drawn scores are greater than the remaining 3 in various combinations. And then moving on from here, if we look at the 3-way slither check, as we've said, we've already made sure that the remaining scores are, the remaining 2 scores are not higher than the scores that we're actually checking that we're equal to. So we don't need to worry about that bit again. So it's simply a case of plumbing in the 6 different combinations here, the 6 different checks from here which feature each of the snakes. So in Nancy's case, the 6 compares here that feature Nancy, we plug into the bool over here. Repeat the same process for the other snakes. The 4-way check over here, exactly the same rule applies. You just come over to the 4-way outcomes, any that involve the snakes you're working with. So any that involve Nancy here, I plug into the inputs of this bool. Repeat the process with the other snakes. The absolute slither, the easiest one on the board, you just take its output and plug it into these conditions for each of the snakes. It's as simple as that. So that's a really easy one. And finally, the overall winners, they're an easy one too, because you just come over to the overall winner checks here, connect Nancy to Nancy, Bonnie to Bonnie, Clyde to Clyde, and of course Dave to Dave. So that's a really easy one as well. So you just wire them up in there, and then you've completed all of the different scenarios. Following on from there, connect the output from the time node to the input or the time input on the monoflop nodes. In your range mappers, the finishing positions for each of the 5 arrows are 80 centimeters apart. So for Sid, the arrow goes from 0 to 443. We then come down to 363 for Nancy. In Bonnie's, it's going to be 283. Clyde, 203. Dave, 123, 123. And then finally, you have to drag in the individual arrows from the arrows list here, from the object manager. So they just come in, drag those into the final object nodes here. That's all you've got to do, and you've got everything wired in and absolutely correct. Okay, so that gives us a recap of everything that we've had to do in order to get this set up. Now let's have a look and see if it actually works and run some tests on this. So what we'll do, I'll just do a quick zoom in on this particular area, so we'll frame those selected. At the moment I've got them all plugged in because I've actually done some pre-checks on these to make sure that they do actually all work, and that I've got them all going. But we'll do a few tests here. So the first one, we checked for Sid and that did work. So let's see if we can do a check for Nancy. Run the test and see if she's okay. Just deselect those. And she certainly is. So that scenario is working fine. And then it's a case of systematically working through each snake to check if they're going to work out as the winners. Once you've done all the winner scenarios, you can move on to the 2-way dead slithers. We'll do one more winning scenario just to prove that it does work with Dave. And it does, okay, so we know that they're okay there. From here onwards, we'll just do a quick check on a few at random. So we'll do, as a 2-way slither, shall we do Sid and Dave? No, let's do Sid and Clyde. Yeah, Sid and Clyde, that'll do nicely. So we'll check Sid and Clyde here. see if those two are working okay. And no problem at all. So we get two-way dead slither out of there, and it indicates as to which ones it would be. A three-way, let's put Bonnie into the mix, and we'll do, how about Nancy, Bonnie and Dave? Let's see what happens there. That gives us a three-way slither combination. Back to the beginning, away we go. Absolutely fine. So Nancy, Bonnie, Dave, that's perfectly good. And then we'll do a four-way. We'll do Sid. Tell you what, we'll do Sid, Nancy, Clyde and Dave for a four-way slither. And there we have it. That's perfectly good. And then finally we'll just put the last one in, put Bonnie back in, and we'll do a five-way dead slither check, so, or absolute slither check. And I've never ever seen an absolute slither in all the times I've been playing around with this. I've got to the stage where I've seen 4, but there you go. That's what an absolute slither would look like if you ever get one. But the odds against it are pretty high, though it's still perfectly possible. But anyway, that pretty much completes the testing for it. As I said, I did obviously go through all the scenarios, and I've made sure that they all work, and they do indeed, I promise you. But if they don't, it's just a case of using the debugging techniques that I've shown you, wiring all of this stuff up, and then systematically working through to the checksums and saying, well, okay, is there anything wrong with any of those? And if there are problems, then just sorting them out from there, and just using a process of deduction by using result nodes in the various different bool outputs and seeing if there's any problems with any of them. And if there are, then you've isolated what the problem is, and the chances are you've just wired something in wrong, and it's a case of just tracing it and wiring it in correctly. It is easily done, but it's relatively easy to fix if you just follow that simple rule. That completes this tutorial, and it pretty much brings us to an end to all of the animation that we need to do for this particular job. In our next tutorial, we're going to take things a step further and start putting the finishing touches to all of this, and the first of those will be to add some sound effects. I look forward to seeing you there very shortly.